Controlling lionfish Pterois volitans and Pterois miles in the Greater Caribbean Basin via culling and biocontrol, by me, Alexander Appelqvist Jansson, and Georgi Maximovic. But first, some information about lionfish. Lionfish might be the perfect invader, as it eats almost anything, almost all fish and crustaceans that fits in its mouth. It habitats a huge variety of habitats, ranging from seagrass, mangroves, coral reef, artificial reefs, and sand dunes, and ranging from depth from surface level down to under 100 meters being observed at. They also have huge dispersal of gametes, uh, making them hard to control. They also have venomous spines, meaning predators have a hard time eating them. Lionfish really like it in the Caribbean and has reached densities up to 15 times their native range, making them one of the greatest environmental issues today because they're replacing native fish. Two methods to control lionfish is culling and biocontrol. Culling, human removal, and biocontrol the effects that the environment has on the native species, such as predation, competition, or parasitism. There are problems with culling and biocontrol of lionfish. Culling because lionfish often hides in crevices, making it difficult for commercial fishing methods to fish them out, meaning spearfishing is the most viable option when it comes to lionfish right now. Biocontrol is also hard in the Caribbean because most potential predators are fished out, meaning lionfish are to roam free. Which comes to our research question. Is it possible to eradicate/control lionfish populations in the Greater Caribbean using culling and/or biocontrol? We researched this by compiling available literature. These are the study sites of the research papers read. Red dots represent human removal studies, culling studies, and green spots represent biocontrol studies. Gray point represents both. When it comes to culling, we found that the most effective method is spear and hand nets. And all the culling papers produced a huge variety of results, ranging from no significant results, 20% difference between culled sites and controlled sites, 30% difference, 50% difference, all the way up to 95% difference. And this difference in frequency is difference in abundance is most likely caused by a difference in frequency. All studies did not have controlled culling, but the ones that had controlled culling frequencies had often had a more chance of being significant if the culling frequency was higher. When it came to non-controlled culling frequencies, the researchers investigated frequently culled sites versus non-frequently culled sites, culled by volunteers. And these frequency culled areas range between significant to non-significant difference in lionfish abundance. Most culling was done at only above 30 meters depth, meaning the surface population can be quickly recolonized by the below 30 meter population because of the huge dispersal of lionfish larvae. Some methods, two studies actually investigated traps below 30 meters, but the most efficient traps did not even reach 15% efficiency compared to spearfishing. So what is the future of culling? Well, if we want culling to work, we need to do it at a higher frequency at deeper depths, as the lionfish population seen quick recovery after culling because of the existing population below 30 meters, the present population below 30 meters. Something that we also need to consider in the future of culling is a change in lionfish behavior. And this has actually already been seen just during the last 2 decades of culling. The change noticed is that lionfish has a greater alertness than the divers, meaning they have a quicker and at a longer distance, they swim away from spearfishers, meaning it gets more difficult to kill lionfish. But something that can outweigh this is human experience, as humans has become much better at culling lionfish, much more quicker compared to a few years ago. When it comes to biocontrol, both consumptive effects and non-consumptive effects have been researched. The consumptive effects, meaning predators eating lionfish, is not present at a regional scale because of the small population of predators. Some studies did measure effect of predators of lionfish, but this was in MPAs which has been present for a long time, meaning only in the places where the predator population was big enough they could control lionfish. When it comes to non-consumptive effects, such as competition for food or shelter, lionfish often wins this competition, with other native fish changing their diet in presence of lionfish, while lionfish does not change their diet. Lionfish also outcompetes for shelter, meaning other native species avoid the shelter if lionfish is present. Something that also can facilitate for lionfish invasion is the naive prey fishes, such as the free-spot damselfish. Free-spot damselfish is a very territorial fish, attacking potential predators that come too close. But free-spot damselfish does not attack lionfish, showing that the prey fish is naive. When it comes to biocontrol, also potential diseases and parasites were investigated. In the early 2018s, we saw a 77% decrease in lionfish abundance, and this was thought to be caused by a lionfish disease. But after research was done, we did not find a communicable pathogen, and the so-called disease was thought to be caused by toxic algae blooms, eutrophication, or too high density of conspecifics, and lionfish had a quick recovery in 2019. Something that can facilitate for lion invasion is parasite concentration also. Lionfish has only around 10% of the parasites compared to native fish. But in the home range, lionfish has the same amount of parasites compared to other native fish, meaning parasites has not yet adapted to lionfish in its invasive range, meaning it could facilitate the lionfish invasion. So if we go back to our research question, is it possible to control and or eradicate lionfish with the help of culling and biocontrol? Well, yes, it is possible if culling is done at a high enough frequency and if biocontrol, if predators are present at a high density. So what we need to do is decrease lionfish populations and increase predator populations, such as groupers. This can be done with a commercial fishery for lionfish, where the commercial fisheries switch from native predators to fishing lionfish. And this is also possible because there is a market for lionfish, and the demand for lionfish is much lower than the actual cost of lionfish. People are willing to buy lionfish to eat, and this has been investigated all throughout the Caribbean region. There is a problem for marketing a fishery for eradication, which would be the goal of a lionfish fishery. Because what happens if the stock actually collapses, even though it's a very small chance? Well, this has actually already been solved in Mexico, where relations between lionfish fisheries and governmental and non-governmental institutions has been done. So the non-governmental and governmental institutions protect the fisheries for a potential after potential collapse, involving them in the conservation efforts, making the fishery a friend of conservation and not an enemy of it. which comes to our conclusion, and that is when it comes to lionfish, which is a very big problem, it can't just be solved by researchers and volunteers. It needs to involve everyone: fisheries, governments, and consumers. Because if we extract the same material over and over again from a changing environment, an environment we want to change, it's just bound to fail. We can't just keep targeting the native community while we have such a big problem, because it is a problem, and in order to fix it we need to change what we're doing right now. Lionfish is a problem we can fix, but it needs everybody to do it. Thank you for listening.